Hey, what's going on, guys? Let's try this problem right here. So in this one, what we are going to do is we are going to use nodal analysis inspection method to find out unknown voltages, right? Now in order to do that, we have to follow these steps. The first step is saying find a reference node with known voltage. So for this one, what we do is we connect the bottom one to the ground, right? In that way, this is going to be zero voltage, right? And the next one, assign voltages to other nodes. So here, other than this one, we have this node and this node. So let's put V1, V2, right? The next one is assign conductance to each resistor. So conductance is G, that is equal to 1 over R. So we know that resistance is 6 ohm right here. So the conductance is going to be 1 over 6, right? So for this one, 1 over 4, right? It's overlapping. I'll write this again. So this is going to be 1 over 4, and for this one this is going to be 1 over 2, right? Now we have assigned the conductance. Now this next step is find the elements of the conductance matrix for each node, GII. So here what we do is we have V1 and V2 and the conductance for each nodes right here. So this node, we only care about this node and this node, right? So this one we call G11, right? Now the conductance, so we have to look at the branches that connected with conductance. So we have one branch here and one branch here. So this conductance, we know that this is 1 over 6, right? So we put 1 over 6 right here, plus, and this one, the other branch that's connected to the V1, that's 1 over 4. So we add them together, and that's going to be the conductance for this branch. I mean this node. So this is going to be, so here we can take 12 as our common denominator. So this is going to be 2 plus 3, and that's going to be 5 over 12, right? Now this is one of our G1, one of our conductance for matrix. Now let's look at another one. Here we have V2, right? So this is going to be G22. And again here we have to look at the branches that's connected to it and branches with conductance. So here we have 1 over 4 plus here we have 1 over 2. So this is going to be 1 over 4 plus 1 over 2, and if here we can take 4 as our common denominator. So this is going to be 1 plus 2, and that gives us 3 over 4, and that is equivalent to 0.75. Now what we have to do is we have to arrange them in matrix, and we put them in diagonals. So whatever the one you found for G11, you put that one in this side, 5 over 12, and this one in the other side, 0.75. So here we put these two in diagonals. Now the next one is between each two nodes. So we have to look at the conductance between V1 and V2. So if you notice, here we have only 1 over 4 conductance, right? So that's going to be right here, and this is going to be 0.25, but here we have to do one extra thing, like we have to put a negative sign, right? This is the main thing you have to remember, because if we keep it as positive, that's going to make whole answer, the answer strong. So we have to put a negative 0.25, negative 0.25, and that's it. After that we put V1, V2, and then now what we have to do is set up the equation in matrix form. Okay, so we have done this part, conductance part. Now the next step what we have to do is we have to look at the current sources entering through this first node. So first node, we know that 10 ampere is entering and 5 ampere is exiting. So this is going to be 10 minus 5. And if you look at the second node, this is 5 ampere is entering, and we don't have any other current source entering or exiting, right? So 5 ampere is entering, so this is going to be plus 5. Now all we have to do is do the Cramer's rules to find out V1 and V2. Now Cramer's rule, what we do is we take the determinant of the original form first. That's going to be basically AD minus BC. Determinant is AD minus BC, right? If you see A, B, C, D, AD minus BC is going to be the determinant. So if I take the determinant for the first one, so let's take the determinant. E is equal to 5/12 and negative 0.25, 0.75, and this side again negative 0.25, and AD minus BC. If you do the AD minus BC, you will get 0.25. Now to do the Cramer's rules, what we do is we swap whatever we are trying to find. So if you want to find V1, you have to swap this one with the first column. So if you swap this one with the first column, again 10 minus 5 is going to be 5. So instead of writing 10 minus 5, we know that I just showed you how to derive the answer, because 10 is entering, 5 is exiting, so 10 minus 5, that's going to be equal to 5. So here if we swap this one with the first column, that's going to be 5/5, 5, 5, and negative 0.25, 0.75. And if you calculate the determinant AD minus BC, that's going to give you 5, right? And for the second one, V2, to calculate V2, we have swapped with the second column. So if you swap with the second column, you are going to have 5/12, negative 0.25. Again here we're going to have 5, 5. And if you find the determinant of this one, that's going to be equal to 3.33, right? Now we have all the determinant and the determinant of the original matrix. Now to find the V1, what we do is we take the first equation, first determinant, the determinant when we swap with the first column, right? And divide by the original determinant. And that's going to be 5/0.25. And if you calculate, that's going to give you 20 volts. So V1 is 20 volts. Now to find V2, we have to put, what? We have to get rid of something. So let's get rid of this part. To calculate V2, we have to divide the second determinant what we found with swapping with the second column, that is 3.33, divided by the original determinant, that is 0.25. And if you calculate this one, you will get 13.33 volt. Now we have the voltages, right? This is our main purpose to do nodal analysis. And if they ask you to find the current, for example, let's say you have I4 going through this, and if you want to find the current, we know that current is equivalent to voltage drop. So here V1 minus V2. V1 we already know that is 20, minus V2 is 13.33 over voltage drop over resistance. So resistance in between that is 4 ohm. And if you calculate this one, you will get 6.67 divided by 4, and that is equivalent to 1.67 ampere. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.